Alright, welcome back. This is the last lesson of Unit 4. This is Lesson 5, Absolute Value Inequalities. So last lesson we talked about absolute value equations. Now we're going to mix our knowledge of those with our knowledge of inequalities and do absolute value inequalities. And your objective's there, so let's get started. Okay, so we're going to solve and graph these. So, absolute value of x is greater than 4. Okay? Well, if the absolute value of x is greater than 4, we have to know numbers that will go in here. Okay, that will have an absolute value greater than 4. Well, we know that 4 has an absolute value of 4. Okay, so numbers bigger than 4 are going to give us an absolute value higher than 4. So like 5 has an absolute value of 5. That's bigger than 4. Okay, but we also know negative 4 has an absolute value of 4. So we need to think what kind of numbers around negative 4 are going to give us an absolute value higher than 4. Well, negative 3, the absolute value of that is 3. That's less than this. So our answer has to be less than negative 4. Okay, because like negative 5 would give us an absolute value of 5. That's bigger than 4. Alright, so if I was going to graph this, x is greater than 4, goes this way, and x is less than negative 4, goes this way. Remember your dots, okay? If it's less than or greater than, then it's got to be an open dot. Okay, let's try another example here. Okay, and actually, I guess we should think about, before we go on to our next example, look at your graph here and think about what kinds of inequalities have graphs that shade away from each other. Okay, those are or inequalities. So basically this is saying x is greater than 4 or x is less than negative 4. Okay, so this greater than sign gave us an or inequality. Let's see what happens next when we have a less than sign. Okay, so the absolute value of x is less than 4. So we got to think about what kinds of positive numbers have an absolute value less than 4. Well, again, an absolute value of 4 is 4. And 3 over here would have an absolute value that's less than 4, because the absolute value of 3 is 3. So x, in this case, has to be less than 4. Okay, so like 3 would have an absolute value less than 4. 2 would have an absolute value less than 4. Okay, now we also, again, we want to set it comparable to a negative. So what kinds of numbers have an absolute value of less than 4 that are around here? Well, if I did negative 5, the absolute value of negative 5 is 5. That's bigger than 4. That's not what we want. We want less than. Okay? So that means like negative 3 would be an answer. So our answer has to be greater than negative 4. Okay? So look at what we did in both of these. Basically, what we did for the first one is took our number, or our x, kept our sign the same, and put this number that we already had. Then when we did the negative version, again, we flipped the sign. Alright, and down here you look at the same thing. X and positive 4, we kept the sign the same. When we did the negative version, we had to flip the sign. Let's see what that does to our graph here. Well, I got a dot at 4 and a dot at negative 4. And if x is less than 4, that goes this way. And if x is greater than negative 4, that goes this way. So that means that shading is going to meet right here in the middle. And graphs with shading in the middle are and inequalities. Okay, so we could write this as negative 4 is less than x, and x is less than 4. There's our and inequality. Okay? Because what this is telling us is our solutions are numbers that are bigger than negative 4, which is what our graph shows, and numbers that are less than positive 4, again, which is what our graph shows. So when we talk about absolute value inequalities, okay, if it's a greater than sign, or a greater than or equal to sign, it's going to be an or inequality, compound inequality. And if the sign is less than or equal to, we're going to get an and inequality. Alright, let's look at some more examples. So we're going to solve these just like we did with the absolute value equations first, okay? So, first thing we want to do is isolate the absolute value term, okay? Well, again, we could, I guess, first change this to addition. Means we're used to doing that. Okay. First we need to isolate the absolute value term. Well, it's already all by itself. This is our absolute value term. Okay. Step 2 is to give the absolute value expression a negative and a positive value. So we're going to have x plus negative 4 with a positive 3 and x plus negative 4 with a negative 3. Now remember what happened in the last slide. When we had the positive version, we kept the sign the same. And when we had the negative version, we had to flip the sign around. Okay, so that's what step 3 is telling us, is we flip the inequality symbol that goes with the negative value. So here we took what was inside the absolute value, kept our sign the same and made it equal to the positive version. Then we took what was inside our absolute value symbol, flipped the sign, and made it comparable to the negative version of this one, okay, the opposite. So it means this is the opposite of this right here. We had to flip the opposite sign. Now we're going to solve each inequality. Okay. Remember on the last slide I told you when we had a less than inequality what happened. Let's think about what kind of graph we should get as we're solving this. Okay, if I solve this, I'm going to add 4 to both sides. So I've got x is less than 7. And here I'm going to add 4 to both sides and get x is greater than 1. Okay, well, now I'm going to write the solution as a compound inequality. Remember we said at the last slide that less thans are going to be and inequalities. Okay, so and inequalities. So x is less than 7 and x has to be bigger than 1. So there's our and inequality. Then we're going to graph this. Okay, so we'll go 0, 2, 4, 6, and 8. We'll put open dots at 1 and 7, and the and inequalities get shaded in the middle here. Okay, now let's do one more example. And actually, before we do that last example, again, we need to make sure we know that for our answer, this is what I'm looking for right here. Okay, can we rewrite this as a compound inequality with a graph as well? Okay, so make sure all your answers, if it tells you to solve it, I want you to, when you solve the inequality, rewrite it as a compound inequality and graph it. Alright, now let's go on to another example. Alright, so first thing we're going to do with this is change it to addition. Okay, so we got the absolute value of 2x plus 1 plus negative 3 is greater than or equal to 6. Now I need to isolate the absolute value term, so I'm going to add 3 to both sides to get the absolute value of 2x plus 1 is greater than or equal to 9. Okay, now we're going to take the absolute value expression and set it equal, or not equal, sorry, compare it to positive 9, and because we didn't change the 9, we're going to keep the absolute value sign the same, or the inequality sign the same. And then over here, we're going to compare it to negative 9 because we're doing the opposite of this number. My sign needs to be the opposite and reverse itself. Then we're simply going to solve this here. So take away 1 from both sides, get 2x is greater than or equal to 8, and then divide by 2. Again, make sure you show all your work. We got x is greater than or equal to 4. And here when we solve this, 2x, negative 9 minus 1 is negative 10. I'm going to divide by 2. I divided by a positive on both sides, so my sign has to stay the same, and I get negative 5 here. So I've got numbers that are going to satisfy this inequality are numbers that are greater than or equal to 4, and numbers that are less than or equal to 5. Okay, remember, we said here when we have a greater than sign, when we rewrite the compound inequality, it's got to be an or. Okay, so we're going to have x is less than or equal to negative 5, or x is greater than or equal to 4. Okay? And I noticed on your first assignment some of us are not putting the or in here. Okay? Make sure when it's an or inequality you have the word or. So x is less than or equal to -5 or x is greater than or equal to 4. And now we're going to graph. So I'll do -6, -4, -2, 0, 2, 4, and 6. We get a closed dot at -5 and a closed dot at 4. It says x is shaded toward numbers less than -5, so we're going this way. Or x is shaded toward numbers that are greater than 4, so we're going this way. And our graph matches the or inequality, okay, because they're shaded away from each other. So here's my complete answer. I've got my compound inequality written and the graph to go with. Okay, so again, I'm going to write up here, less than or equal to are and inequalities. And greater than or equal to are or compound inequalities. Okay? Don't forget that step to rewrite as a compound inequality and graph it. Alright, good luck on your homework. If you have any questions, ask.